Hey guys, this is Derek Duplessis, host of Purpose Rockstar. It's a podcast where we interview people who found purpose in their career in all kinds of fields. Today's interview is with Sara Seager. Not only is she a good friend, but she's also one of the most well-known astrophysicists in the world. You'll see her all over the place in Ancient Aliens or on the Star Trek DVD. She's everywhere. But in this interview, you actually get to understand the person behind all of the science. And I think you really will enjoy this.
Now, if you could take us to the flip side, whether it's with dealing with your husband's death or just in your career, what was an aha moment that told you that you were on the right path?
Well, I'll give you one small one, and in the meantime, I'll think in the background of a bigger one. But I never forget when I had my first success for myself. This is nothing the world might care about, but for me, I had written a computer code, and I had generated like a theoretical spectrum. I had actually generated what an atmosphere of an exoplanet far away would look like, and I was so excited. I knew it was the right answer because, our planet, we have a lot of reflection. Like on a bright day when you see clouds are bright or the sand is bright or something's bright. Well, light from the sun comes in, gets reflected off Earth, and goes back into space. Now, if someone has a telescope and is looking from far away, partly what they see in that reflection is the sunlight itself, right? Because the sunlight is what's hitting the Earth and getting reflected. And in that reflection is encoded gases that are in the star's atmosphere, as well as what's in the planet's atmosphere. So when I wrote my code, I saw the reflection of the star, the fake starlight that I'd put in, and so I knew that I had done it right. And I can't remember rarely being that excited that, wow, I worked so hard, I got this thing done, and wow, look at that. That was like a real aha moment. It was like, wow, I can do this.
Beautiful.
That was definitely one of my best aha moments ever.
Yeah, it's something that I can appreciate. Obviously, I've never done any models, coding or anything, but once you sort of do something, like for me, this podcast is one thing, and it's successful, you're like, oh, wow, okay, I can move forward. You just have momentum. So I really appreciate that story. Now, let's get into the nitty-gritty of your work now. Give us the sort of 60-second commercial of your work and what your team is working on in concert with you.
Yes, I'm really happy to tell you about that. Every star in the sky is a sun. And our sun has planets. We have 8 planets, or 9 if you include Pluto. And so we might think that all the other stars or suns out there should have planets also. And they do. But it's only been in the last 20 years that astronomers have had the precision in their tools to actually find planets orbiting stars other than the sun. We call them exoplanets. And you know what? We know of thousands of exoplanets in our own galaxy. We know that every single star in our Milky Way galaxy should have at least one planet. And there's 100 billion stars in our galaxy. And you know what? We think there's 100 billion galaxies. There's a lot out there. My work specifically falls into 2 categories, let's say. One category is these computer models to predict and interpret data. We get data from like the Hubble Space Telescope or other space and ground-based telescopes, and we try to understand what planets are made of. Are they rocky like Earth? Are they mostly hydrogen, helium like Jupiter, or something else entirely? We also try to understand what the planet's atmospheres are made of, and right now we have a few dozen exoplanet atmospheres that have been studied. My second type of work I do is space engineering, where we try to figure out how to detect planets. And mostly for exoplanets, we want to go above the blurring effects of Earth's atmosphere. Being here on Earth and using a telescope, it's like when you're underwater in a swimming pool or a lake and you look up, all you see is like blotchy blurs, blotchy patches. Our atmosphere is actually very turbulent and it really messes up starlight. That's why if you ever look at a star and see it twinkle, it's because our atmosphere is messing up the starlight. So we want to consider which types of space telescopes are the best that we have to build or should be thinking about. And I'll come back to that for a later question. But I'll leave you with one more thing about what I do, and that is what we ultimately want to do here is try to find another Earth. We want to know if there's a planet like Earth out there somewhere, not too far from here, but orbiting another star like the sun, and that a planet that could host life, and that maybe does host life. And that's my job.
Beautiful. Now, we can go in so many different directions, but I just have a couple questions for you. Tell us about an exoplanet that's really interesting to you. Just describe it and why it's actually interesting to you.
The funny thing is I'm going to be teaching a class later today, so this type of thing's fresh in my mind. One of my favorite exoplanets of all times is called Kepler 10b. It's named after the Kepler Space Telescope, which found this planet. And Kepler 10b is a remarkable planet. It's a little bigger than Earth, a little more massive. But what's so crazy about it is it orbits its star very quickly. So instead of taking 1 year to go around its sun, its star, it only takes a fraction of a day.
Wow.
What that means is because planets closer to the star go around faster because of something called Kepler's third law. Planets that orbit their star closer go around faster. This planet is so close to the star, it is heated to temperatures so hot that it can melt rock. Think about that. That's like a volcano temperature. Super hot. So I really like Kepler 10b because it's a rocky planet, but it's so close to the star that the surface gets melted by the starlight.
Very cool.
You know, there's more to that interview. Yeah, more. And you can find all of it at purposerockstar.com. Link is right there. Yeah, right there. Yeah, right there. So it's really, really awesome that you can go to purposerockstar.com. If you're one of those on-the-go Apple people, you can check it out on iTunes. There's the link. And for my non-Apple people, I'm going to make sure there's a link on Stitcher somewhere next to me. So you got iTunes, Stitcher, and purposerockstar.com. Tell your friends, tell your family. We're on Twitter and Facebook, and somehow we'll be on LinkedIn. I don't know. But at least we'll be on Twitter and Facebook. And one final favor. Pursue your purpose. It needs you.
To find another Earth. And there are many ways we can imagine to find another Earth, but the concept for which I'm leading a team who is studying it, we think is the shortest path to finding another true Earth.